Now, before we move forward, do we have any questions?
Just to confirm, like, so the epoch is called like when all the data set is seen, or once like one mini batch is seen by the neural network.
So
One epoch
one
is
mini batch, yeah, when one mini batch is seen, that's like one iteration.
okay.
Okay,
Oh, I see. Okay. Okay. Thank you.
because you updated like each weights like once, so that's one iteration. And then once your network has seen all the images, that's like one epoch. So one epoch will have several iterations.
Okay.
So for example, if your data set size is 100,000 and your batch is, let's say, 100, then you will have like 1,000 iterations in one epoch.
Okay.
And professor, we will assign weights like one weight to one epoch and then another weight to another epoch with different learning weights, right?
Can you repeat that?
We will assign different weights to different epochs along with different learning rates. Is that right?
No, so okay, let me go back. Yeah, we'll go over this like in more detail in further slides, but let me try to clarify that. So you have designed your network, you have your training set, you have your loss functions, everything is ready. Now you initialize your weights randomly. That's just once at the beginning, and it's done. Okay, so that's kind of I mean, you have the network, and that network can make prediction, but it will be very bad prediction. But that's a starting point. You do that only once,
So
and
weight is
then the
assigned
learning
only once.
process. Yeah, only once, and then the learning process
Okay.
begins.
Okay. Got it. Thank
Okay,
you.
so that point, if you think about this, it's exactly the curve I showed you. So this point over here, that is like that step you initialize, and this is the loss value at that point. And then like you will train on one batch, your curve will move like in this direction, and it will keep moving like with each iteration, each epoch, until you are at this point. And again, this is just showing for one hyperparameter, right, in one dimensional. But try to visualize this like you have lot of millions of hyperparameters, right? So for each hyperparameter, you're actually repeating the same process. It's going to the minimum.
That's a lot of computation.
That's a lot of computation. That's true. That's why it takes time, and that's why we use GPUs. All right. So any other question before we move forward? I think there is a question which is like quite off topic. Submission of code should be in PY or Python notebook. Yeah, I mean, if you can submit the Python, like the raw file, that will be good. But if it's too difficult for you, you can submit the notebook as well. But submit the full code. Okay, no links. All right, sorry about that. That was it. Anyways, so okay, so that's like a high level idea of how the training process works and how we compute the gradients and why we need the gradients. And that was due to like the gradient descent algorithm we are using. So how those like mini steps you're taking towards the gradient direction is actually helping you lower the loss value and making the network prediction better. Okay, so let's move on. All right, so any questions until this part? We still have some more slides. Okay, let me first go through the chat. Okay, question from Mohammed. What will happen if you have a huge memory and can load all data at once? Does it mean that the training can be considered complete after one epoch? So even if you're able to fit like all the samples in your memory, you usually don't do that. You still train like on mini batches. And the idea is like using mini batches, it gives you like some sense of where to go, but again, it tries to avoid like that overfitting scenario, right? Where you look at like all the samples, and if you have sufficient parameters, it will just go to some local minima where overfitting is being performed. So ideally, you have this hyperparameter batch size. So you train on still train on batches, But training is never complete like after one epoch. One epoch is just when your network has seen sample once, and just looking once is not enough. So again, it depends, but we have seen like some networks which were trained for like thousands of epochs, maybe 10,000 epochs, right? But again, that varies a lot, but that's kind of a just to give you a sense of how this goes. So usually you train for maybe 10, 20 epochs, 30 epochs, or maybe 100 epochs. So you'll have to see like each image multiple times. Okay, second part was assuming learning rate is equals to 1. So to incorporate loss over all data too. No, learning rate has nothing to do with the epochs or the iterations, right? Learning rate equals to 1. There is no correlation actually. When learning rate is 1, it just says like what will be your step size, right? And for different data sets, for different architectures, that learning rate might have like different optimal value, right? So that learning rate is your unit step in your loss curve. And that loss curve is actually dependent on your network, how many parameters you have. So there is no direct correlation between those two. Learning rate is just defining like how small or how big your steps are going to be. Okay, so it's completely independent. So Mohammed, I hope that answered your question. Okay, good. Let's move on to the next one. Can we change the learning rate through the training process? Manually, when that was 2012. If the scheduler sees that okay, your loss is not changing or your performance is not improving, it will automatically reduce your learning rate for you. So there are ways to do that. But the intuition is, let's say you're starting at this point. So you don't want to take small steps at this flat surface, right? I mean, it doesn't matter if you take small steps or big steps. You're still going in this direction. Okay. So initially you take big steps, but as you go closer, which means your gradients are actually, your slope is reducing, which means you are going closer to your local minima, then you reduce your learning rate. So the earlier scenario I explained, if you have a learning rate, which is, let's say, this much unit going from A3 to A stop, right? So what will happen if you are at A3, then if you have that learning rate, it will just jump. It will cross the local minima and it will keep jumping. Because from this point, it will say, okay, you should move to the right because your gradient is negative and you will have a high learning rate. It will go to this point. At this point, it will say the gradient is positive. You should go to the left direction. Again, the learning rate is high. It will jump the minimum point. So it will keep jumping, which means the loss is not changing. Then what you do is you say, okay, let's reduce the learning rate. Then you will take smaller steps. And then again, you will keep moving towards the local minimum. I hope that was clear. But yeah, I think that was a good point. A question from Jayakumar. Will neurons in input and output layer get dropout? Yeah, I think that's very interesting because a recent like research, I don't know whether you have heard about that, and it's fine if you haven't. It's called like mask autoencoding, and the idea there is you hide your input data. So for example, if you have image, you like hide some of the patches and then ask your network to actually predict the hidden patches. So you can think about this. If your network can do that, it means it's actually doing a good learning, right? It can extrapolate what is actually looking at. For example, if let's say I send the network my image, but I hide like this patch, let's say the right eye. And I ask the network to actually reconstruct this part by just looking at the other region of the image. And if it can do a good job, then it means that it has a true understanding of, okay, it's a human and there should be 2 eyes and all that. So that actually quite well relates to what you are saying, Jaykumar. So you are dropping actually those input data points. Okay, so that's one part, but the output you should not drop, because that's actually making the prediction, right? So I don't know what that will mean, because I mean, just the layer before your output, yeah, you do drop out. That's a very good idea. And of course, you can perform dropout in any of the layers. But the final layer is actually giving you predictions, right? Which means that you need like every prediction. So I don't know what dropout will mean there. So for example, if you have 1,000 classes, you do want to predict 1,000 classes, right? It's not that sometimes you will predict 50 classes and sometimes the other 50. But before that, you can perform dropout. Okay, question from Ahmed. So yeah, Jaykumar, I hope that was clear. In dropout, are the neurons that are turned off the same through the whole? No, we keep we change them like every iteration or every few iterations or every epoch. Okay, so we keep changing them. Okay, another question from Nasir. We are almost out of time, so let me try to cover this one. What is the loss function inside the sum? Sigma has Li. Yeah, that I subscript should be like for the sample, right? So for each sample, you will compute the loss and you will average that across all the samples in the batch. Let me go through that. This one, right? Yeah, I mean, yeah, that's just indicating like loss for each sample. Ideally, you will use the same function for all the samples. So even if you skip that part, that's fine. Yeah, I understand your doubt. So we don't have to have like I at this point. It's fine. Okay, is it not the same loss function used for? Yeah, I think we just covered that. It's the same loss function. Second question is dropout used only during training or during inference? And that's a very good question. Ideally, we don't use dropout during inference, right? So whatever you have learned, you will want to make use of all those neurons, right, in your inference. But that said, like there are certain scenarios where actually if you don't use dropout, it's actually better. And I won't go like too detail into too detail of that, because it might be complicated, but yeah, there are some scenarios where dropout is actually useful. If you want to know more, like I think you can just send me an email, we can discuss more about it, but that will be a diversion from the computer vision topic, or at least this course. All right. Okay, so I think we covered all the questions and we are almost out of time. So thank you very much. Let's end it here. I'll see you on Thursday.